Speech emotion analysis is an exciting project because it teaches you how machines can understand human emotions from voice, and this skill is rapidly becoming essential for modern AI engineers. In this slide, we look at how an AI system listens to speech patterns and identifies feelings like happiness, anger, fear, or calmness using audio features and deep learning. This matters in 2025 to 2027 because companies want AI that can respond to human emotions in real time. It improves customer support, enhances healthcare solutions, and even powers safer driving experiences. You can imagine call centers checking agent tone, or voice assistants adjusting their replies based on how you sound. You also see uses in mental health, aiming, and sentiment analysis for research teams. Industries hiring include healthcare tech, automotive, service platforms, and entertainment. Recruiters value people who understand audio data and can build emotion-aware systems. This project gives you a strong foundation for roles in audio AI and conversational intelligence. This slide focuses on the skills you need to build a speech emotion analysis system, and these skills are incredibly valuable for early career AI professionals. You learn audio signal processing, which teaches you how sound actually behaves. You also study feature extraction, where you work with MFCCs and spectrograms that convert sound into useful patterns for models. Deep learning is a core part, especially CNNs, LSTMs, and transformer-based approaches for temporal data. Tools like Labrosa, TensorFlow, PyTorch, and SpeechBrain help you train and evaluate your models efficiently. Soft skills matter too, because you need to interpret emotional patterns, handle cultural differences, and think about privacy and ethics in emotion AI. Recruiters appreciate candidates who understand real-world audio challenges and can explain model behavior clearly. This skill set opens doors in speech tech companies, voice assistant teams, and AI product roles that depend heavily on understanding human emotion. Here we break down the full implementation roadmap so you understand exactly how to build this project from scratch. You start with dataset collection using open datasets like RavDes and TESS, ensuring you gather diverse voices and balanced emotion classes. Then you pre-process the audio by normalizing length, removing silence, reducing noise, and slicing audio into fixed segments. Next, you extract features. You compute MFCCs, generate MEL spectrograms, and capture pitch and energy patterns. After that, you develop your model. You begin with CNNs for spectrogram analysis and then try LSTMs for temporal patterns. You can also experiment with hybrids or attention-based methods for better accuracy. Finally, you evaluate your system on unseen speakers and aim for real-time inference before deploying with a simple interface. Beginners take around 6 to 8 weeks, while intermediate learners may finish in 3 to 5 weeks. This roadmap mirrors how audio AI teams build production-grade systems. This final slide highlights how the speech emotion analysis project strengthens your career prospects and opens high-value job roles across audio AI and voice technology. You can aim for roles like audio AI engineer, speech recognition specialist, ML engineer for audio systems, or voice tech developer for companies building assistants like Alexa, Google Assistant, or Siri. Recruiters look for engineers who understand both deep learning and audio patterns, and they value applicants who can handle noisy real-world data. They also appreciate candidates who understand emotional psychology and can design ethical emotion-aware systems. Resume keywords include emotion recognition, MFCC, spectrograms, CNN-LTM, Labrosa, and PyTorch. Hiring demand is strong across big tech, healthcare AI startups, automotive companies, and call center software providers. Salary ranges are impressive, with India offering 7 to 22 lakhs and global roles reaching up to $195,000. Start building this today and put it on GitHub.